solving systems of linear equations using matrices. A system of equations is several equations or as many equations that you have as unknowns. And in this system, we have three unknowns, x, y, and z. Therefore, we need three equations. And you can do a substitution to solve for this. And it can, as you remember, this can get quite messy. So today we're going to use an augmented matrix. You notice that we have no x's in the second equation and no x's or y's in the third equation. And when we put it in a matrix, an augmented matrix, we're just bringing the coefficients from each of these variables into this grid-like format, which is a matrix. So 1x minus 2y plus 3z is equal to 9, and so on. There's our three equations. So you can see that z represents 1z is equal to 2 in this one. All right, in this lesson, you will be using back substitutions to solve a linear system of equations in row echelon form. And we will be using Gaussian elimination to solve systems of linear equations. Let's look at our system here. Here's a system. Notice that we have no x's in here and no x's or y's in the third one. This is in row echelon form. Okay, well, we have 3 zeros here. That's what we want to end up with because we already know what z is. If we know what z is, then we can come back up here and know what y is because 3 plus 3 times 3 is equal to 6. So we know that y is negative 3, and we can back substitute up here with a 3 for z and a negative 3 for y, and we can solve for x. So that's why we like this format. So our goal is to get these into zeros. The thing you can keep in mind is we want to get these two zeros first. The order of these two don't really matter. And then we try to get this to be 0. If you try to get this to 0 first, you might end up creating a new x, which you didn't want. Okay, so let's try an example here. Here's a system of 3 variables with 3 equations. And I'm going to first write the augmented matrix for that, putting all coefficients in this grid format. And now my goal is to get this into row echelon form, meaning that these 3 numbers have to be 0, these 3 coefficients, the one on the x and this x and that y. So we're going to try and eliminate this x first. Now, this is kind of complicated. So if you look here, if I add these 2 rows, row 1 and row 2, I've named them here in red, I can get a 0 here. That's what I wanted. So when I add these 2 rows, I'm going to put the sum back in the middle row. Okay, like this. I'm going to add the first 2 rows here and put that answer down in the middle row so that I can eliminate this first x. Okay, let me walk through that again. 1 plus a negative 1 is 0. Negative 2 plus 3 is positive 1. 3 plus 0 is 3. And 9 plus negative 4 is 5. That's how I got that row. Now I want to eliminate this coefficient here, the 2. Well, I can't just add the 1 to it, but I could add a negative 2 to the 2. So if I multiply this first row by a negative 2, now I can add these together, right? If I add these together, I will get a new row down here with a 0 in the front. So first I multiply this row by a negative 2, and I got this. I don't change the numbers in this row or this one, but after I add these two, I put that in the third row. Now I've got 2 zeros here, and all these have changed, right? 2 plus a negative 2 is 0. Negative 5 plus 4 is negative 1. 5 plus negative 6 is negative 1. And 17 plus a negative 18 is negative 1. Now all we have to do is get rid of this y. Okay, this one right here, which now is negative 1. Well, I can add these two together, right? So I put these in blue to refer to this matrix and not the original one. If I add the second and the third row together and put that answer on the bottom row, I would eliminate that one because 1 plus a negative 1 is 0, 3 plus a negative 1 is 2, and 5 plus negative 1 is 4. Then we have this format here, right? Putting all the x, y's, and z's back in my grid with the zeros in here. And I can see that now 2z is equal to 4, or z is equal to 2. And then we can back substitute all the way up this way and get 1 for x, negative 1 for y, and 2 for z, which we got from here. Okay, let's do another one. Here's another system. If you are good, then you can try this and pause the video and come back and check your work. If you need a little extra help, then still pause the video and try and get as far as you can, and then come back and just look if you need a little nudge or check your work after you've tried it. Okay, so I've written my augmented matrix. I want these three numbers to be 0. And I see that 1 and a 2 there, so I'm going to try and turn that 1 into a negative 2. So I multiply that whole row by a negative 2. And when I add that to the second row here, my new second row will be a 0, negative 3, negative 1, and negative 9. Now I'm going to do a similar thing to get rid of this 3. I would have to multiply the top row by a negative 3, and then add that to the bottom row and put that as my new bottom row down here. All right, so now I need to get rid of this 2. Well, there's no good way to, I don't want to use this one because if I try to use a top row, I'm going to end up with a new number up here, and that would just bring me back full circle to this matrix up here, so I don't want to do that. So I'm only using the bottom 2. So I'm going to multiply this one, how about by a 2, and this one by negative 3. All right, so if I multiply this one by 2 and that by negative 3, I create a negative 6 and a positive 6. So that will give me a 0 down here. Multiplying the negative 1 by 2, I get a negative 2, and negative 3 plus times a negative 4 is positive 12. Add the negative 2 and the positive 12, I get a 10. And then a negative 9 times 2 is negative 18. And 3 times, negative 3 times negative 16 is a 48. Positive 48 plus 18 gives me positive 30. Now I have my row echelon form. Just a quick little tidbit here. True row echelon form has all ones here, 1 and 1 and 1, with all these other numbers as something else. So that would that's a little tedious, and I don't think it's necessary because you know that you can divide both of these numbers by 10 to get a 1 here. This would be 1z is equal to 3, which is what we want anyway. Okay, but then when you get up to here, you have to divide everything by 3, so you end up with 1, which is nice, but then you get a fraction here of 1/3. So I think that looks a little messy, so it's okay if these are not all 1. All right, so, and then back substituting, we get 3 times 10 is 30, and putting that 3 into this z, I can solve for y. Once I solve for y, I get 2, and I can put those back into z and y. I can get x as 1. Let's try one more on your own here. Pause the video now and make sure that you can get this and use the next segment of this video to just check your work. That's the only way to learn, right? Math is a skill that you have to do. You can't just sit here and watch and be an expert at it. Okay, I hope you got farther this time and maybe even finished it. Let's check your work. Here's my augmented matrix. I want those to be 0. And I first added the top 2 to get rid of this first x in this middle row. And then I multiplied the top one by a -2 and added it to the bottom one. I got another 0. And I added these two to the third one to make this a 0. There we go. I called this one 4 and 5 just because I didn't want to get mixed up with these 1 and 2 and 3 up here. So that's it. So that's 3 times z is 6. That would give me a 2 for z. And back going up here, -1 for y. And so on. And you can get z. Okay. Try this one. This one has a little twist in it. When you get stuck, come back because you might be super intelligent and figure out something here, or you might just think you made a mistake because something funny goes on in this one. All right, I hope that you give it your best attempt, and once you get to the end here, when I do this, I get no x's, no y's, and no z's is equal to -2. Well, when is 0 equal to -2? That can't ever happen. So that means there is no solution. Or in other words, that these three equations don't have something in common. So that's why we get something that is not true. If you get like 5 is equal to 7 or something like that, double check your work, make sure that you didn't make a math error. But if this is the true answer, then there's no solution. Okay, all right. Here is example number 6. See if you can finish this on your own. Check your work. All right, so hope you gave it a good try here. Here we go. So when you put this in the augmented matrix, you get this. Eliminate the 3, 2, and the 2. First, I multiply the first one by a -3. Add it. And I get 1, 7, 11. Then to get rid of this 2, I multiply the top one by a -2 and add it. Then to get rid of this 2, I multiply this one by a -2. And I get this. And that means that x is going to be 2. And back substituting, I get -3 for y and 1 for x. All right, here's some links for other videos, other presenters of this kind of problem so that you can get some extra help. Please, send me any questions that you have, and I'll be happy to work with you. All right, thanks.